we imagine the solar system, we usually picture the 8 major planets, the inner rocky worlds, the gas giants, the ice giants, and maybe a few dwarf planets, along with some comets and asteroids. But beyond Neptune lies a region filled with worlds, hundreds of them. Many of them are large enough and round enough to qualify as dwarf planets. Yet there are only 5 objects that are officially recognized as dwarf planets: Ceres, Pluto, Makemake, Haumea, and Eris. So today, let's travel through the distant region of the Kuiper Belt to explore 10 of the largest dwarf planet candidates. Let's begin with Gonggong. Gonggong is named after a Chinese water god. As we approach, the first thing we notice is its color, a deep reddish brown that stands out against the black. The color comes from tholins, organic compounds created when sunlight interacts with methane. Even way out here, far from the sun, its energy fuels chemistry and continues to help shape these distant worlds. Gonggong is about 1,230 kilometers, or 764 miles across, with an uncertainty of about 50 kilometers, or 31 miles. It orbits the Sun at an average distance of about 10.1 billion kilometers, or 6.3 billion miles. As we descend toward the surface, we can see patches of water ice mixed with darker material. Some regions look smoothed, almost as if cryovolcanic activity once reshaped them. If ice volcanoes ever erupted here, they would have released slurries of water and antifreeze compounds into the cold vacuum. The temperature is about minus 242 degrees Celsius, or minus 404 degrees Fahrenheit. Scientific instruments detect a trace of atmosphere, but it is thin and unstable. Any gas that rises here will eventually escape into space. A day on Gonggong lasts about 22 hours. A full year here lasts 547 Earth years. We leave Gonggong behind and continue inward toward a smaller but equally intriguing world. Welcome to Máni. Máni is named after the personification of the moon in Old Norse mythology. As we approach, the surface reflects light in a way that suggests the presence of ice. Máni is about 796 kilometers, or 495 miles across, with an uncertainty of 24 kilometers, or 15 miles. It orbits the Sun at an average distance of about 6.24 billion kilometers, or 3.88 billion miles. The surface contains crystalline water ice, amorphous water ice, and carbon dioxide ice. The temperature is about minus 208 degrees Celsius, or minus 343 degrees Fahrenheit. There is no detectable atmosphere, and no moons are known. Máni rotates once every 14.25 hours. Its orbit around the Sun takes 269.5 years. The landscape is quiet and unchanging, shaped by only impacts and the freeze of deep space. We set course for a larger and more complex world. This is Quaoar. Quaoar is named for the creator god of the Tongva people. It comes into view as a reddish sphere with a surprisingly dynamic environment. Quaoar measures about 1,097.6 kilometers, or 682 miles across, with an uncertainty of only a couple of kilometers. It orbits the Sun at an average distance of about 6.27 billion kilometers, or 3.90 billion miles. As we approach, we can see its moon, Quaoar, circling slowly. Even more surprising is the faint ring system. Rings around a body this small are rare. They are not expected to be stable so close to the object, yet here they are. The surface of Quaoar is a mixture of crystalline water ice, tholins, and frozen methane. Temperatures fall to about minus 228 degrees Celsius, or minus 379 degrees Fahrenheit. Some observations suggest that Quaoar may have a relatively thick hydrocarbon atmosphere, possibly dominated by methane. Its rotation period is about 17.68 hours. Subtle color variations hint at geological processes we do not yet understand. We continue onward toward a darker, more mysterious world. We are approaching Achlys. Achlys is named after the personification of grief and sorrow in Greek literature. Achlys is about 772 kilometers, or 480 miles across, with an uncertainty of 12 kilometers, or 7.5 miles. It orbits the Sun at an average distance of about 5.9 billion kilometers, or 3.67 billion miles. As we descend, the surface appears dark gray, almost charcoal-colored. Water ice is present, but it is mixed with darker material that absorbs most of the light. The temperature is about minus 220 degrees Celsius, or minus 364 degrees Fahrenheit. Achlys once appeared to have a moon. It was observed briefly, then lost. Astronomers have not been able to locate it again. The rotation period is 6.8 hours, and there is no significant atmosphere present. We leave Achlys behind and head toward a world that shares an orbital rhythm with Pluto. This is Orcus. Orcus is named after a Roman god of the underworld. Orcus is about 910 kilometers, or 565 miles across, with an uncertainty range of plus 50 and minus 40 kilometers, or plus 31 and minus 25 miles. It orbits the Sun at an average distance of about 5.86 billion kilometers, or 3.64 billion miles. Its orbit is locked in a resonance with Neptune, just like Pluto, but positioned on the opposite side. For this reason, Orcus is sometimes called the anti-Pluto. As we approach, we see its moon Vanth orbiting closely. Vanth is large relative to Orcus, and the two bodies may even be tidally locked. The surface of Orcus is relatively neutral in color, with a bright equatorial region. Temperatures fall to about minus 228 degrees Celsius, or minus 379 degrees Fahrenheit. No significant atmosphere is present here. The rotation period is uncertain, with estimates ranging from 7 to 21 hours. We continue outward again, toward a world named for the dawn. We now approach Aya. Aya is named after the goddess of dawn in Akkadian mythology. Aya is about 768 kilometers, or 477 miles across, with an uncertainty range of 39 kilometers, or 24 miles. It orbits the Sun at an average distance of about 7.06 billion kilometers, or 4.39 billion miles. Its surface has a moderately red tint, likely caused by organic compounds. The rotation period is roughly 8.8 hours. Temperatures fall to about minus 233 degrees Celsius, or minus 388 degrees Fahrenheit here, and it has no moons. The landscape appears smooth in some regions, and textured in others. Ahead of us lies one of the most distant objects ever discovered in our solar system. This is Sedna. Sedna is named after the Inuit goddess of the sea and marine animals. Sedna is about 906 kilometers, or 563 miles across, but the uncertainty range is enormous. It could be more than 300 kilometers, or 186 miles larger, or more than 250 kilometers, or 155 miles smaller. It orbits the Sun at an average distance of more than 75 billion kilometers, or 46.6 billion miles. A single orbit takes Sedna about 11,400 years. The Sun is a distant point of light, barely brighter than a distant star. The surface is reddish, likely due to tholins. Temperatures fall to about minus 240 degrees Celsius, or minus 400 degrees Fahrenheit. No atmosphere or moons are known. Sedna's rotation period is still debated, but recent observations suggest it is around 10 hours. We turn back toward the inner Kuiper Belt, where another reddish world awaits. This is Varda. Varda is named after the Queen of the Valar in Tolkien's writings. Varda is about 740 kilometers, or 460 miles across, with an uncertainty of 14 kilometers, or 8.7 miles. It orbits the Sun at an average distance of about 6.9 billion kilometers, or 4.29 billion miles. Its moon, Ilmare, orbits nearby. The two objects may have formed together after a collision. The surface of Varda is dark and reddish, containing methanol ice rather than water ice. Temperatures fall to about minus 224 degrees Celsius, or minus 371 degrees Fahrenheit. The rotation period is roughly 5.9 hours. We continue toward a world named after a sea goddess. This is Salacia. Salacia is named after the Roman goddess of saltwater and wife of Neptune. Salacia measures about 838 kilometers, or 521 miles across, with an uncertainty of 44 kilometers, or 27 miles. It orbits the Sun at an average distance of about 6.31 billion kilometers, or 3.92 billion miles. Its moon, Achlys, orbits at a distance that allows astronomers to calculate Salacia's mass with good accuracy. The surface contains water ice, mixed with darker material. Temperatures fall to about minus 230 degrees Celsius, or minus 382 degrees Fahrenheit. The rotation period of Salacia is about 6.1 hours. One final world remains on this journey. This is Ixion. Ixion is named after the king of the Lapids in Greek mythology. Ixion is about 709.6 kilometers, or 441 miles across, with an uncertainty of 0.2 kilometers, or 0.12 miles. It orbits the Sun at an average distance of about 5.89 billion kilometers, or 3.66 billion miles. Its surface is dark and moderately red due to organic compounds. Water ice is suspected on and beneath the surface. Temperatures fall to about minus 209 degrees Celsius, or minus 344 degrees Fahrenheit. The rotation period of Ixion is about 12.5 hours. These 10 worlds are only a small sample of what exists beyond Neptune. The Kuiper Belt contains hundreds of objects that are large enough and round enough to qualify as dwarf planets. Many remain unconfirmed, many remain unnamed, and most have never been seen up close. The official confirmation and naming of these objects is in the hands of the IAU, or International Astronomical Union. The solar system is vast, and it is still slowly revealing itself. The more we explore these distant objects, the more we understand our origins and our place within it. Which of these distant worlds would you visit if you had the chance? Let me know in the comments below. If you enjoyed this exploration of these Kuiper Belt objects, feel free to show your support with a like, or by sharing this video with other curious minds. Subscribe and hit the bell icon so you don't miss the next journey through the cosmos. Thank you so much for joining me today. Until next time, my friends, take care and be well.